Think of a race car speeding along a straight track. It is an example of the simplest form of motion, motion in one dimension. The race car goes forward and backward only. How do displacement and velocity change as you adjust the acceleration of a race car? Adjust the acceleration of the race car by moving the slider. Look at the graphs to see how displacement, velocity, and acceleration change over time. You can experiment with changing the car's acceleration or pause the animation to look more closely at the results. Click Reset to begin again. Each column shows graphs of displacement and acceleration for the same moving car. Which graph of velocity matches each situation? Drag the correct graph into each space, then click OK. Not quite. Use the feature to check your answers and try again. Remember that velocity is the rate of change in displacement and acceleration is the rate of change in velocity. The correct answers are shown. Click Learn More for more information on why the answer is correct in each case. When the car slows down, acceleration is negative and velocity decreases. Displacement remains positive, but it doesn't increase as quickly as when acceleration is positive and velocity increases. For situations with constant acceleration, such as those you saw in the previous understanding activity, displacement can be calculated from velocity, acceleration, and elapsed time using this quadratic equation. Click each variable in the equation to see what it represents. Delta x is the displacement, that is, the difference between the ending and starting positions. V initial is the initial velocity of the object. Delta t is the change in time, that is, the final time minus the initial time. A is the acceleration, that is, the rate of change in velocity. For this equation to be valid, acceleration must be constant over a given time period.